we will talk about time series analysis today, and we will analyze the precipitation data from 1984 to 2024. Almost for 40 years, we are going to analyze that data for Chennai area. Okay, and we will see how it has, whether the precipitation has increased or what are the special months in which there is more rainfall in that particular area, and how it has changed over time. Okay, so what were the years in which there was more rainfall than the normal? So we will try to find out all these things. So for this analysis, we will use Google Earth Engine dataset. We will use CHIRPS precipitation data that we have already used in our previous exercises as well. So I hope now you're familiar with the name at least. And time series analysis is, if you talk about geosciences or any other field, it involves like analyzing the data points collected over time. Okay, so you may have 10 years of time and 20 years of time. It can be centuries. Okay, and it can be decadal, any time period for which some data points are collected, and we try to understand and predict the changes. Okay, so when we try to analyze the data and predict the changes, so this is still like, so let's say we have data till 2024. Okay, 2025 is not ended yet, and for 2025, based on this 40-year analysis, we can at least predict some precipitation pattern for 2025, or let's say for upcoming 5 years or 10 years. Okay, so that's why your time series analysis, it not only tells you about the historical patterns or trends, but it also helps you in forecasting or predicting what could be the patterns for future. Okay, and it is applicable to your disciplines like climate science and seismology, how the seismicity has changed over time if you want to perform that analysis, how in hydrological analysis, how groundwater regime, or how groundwater let's say how water levels has fluctuated over time. Okay, so whatever things you want to analyze over time, you can perform time series for that. Okay, so I'm going to give you some line of codes for which you can use Google Earth Engine dataset, and you can analyze that quite easily. Okay, but for your own analysis, you have to search for the data sets available within Google Earth Engine, or if you have or if there are any other websites available. For example, you can, if you are working in a seismology domain, then you can go to USGS website and download the data, earthquake data. Okay, and if you are working in let's say hydrology, you can go to, if you're, and you, especially if you're interested in Indian groundwater regime changes, then what you can do, you can go to Central Groundwater Board website, and from there you can get the historical data and analyze those patterns. Okay, but the way the data is present, it varies. Sometimes it is already readily available in the form of Excel sheets. Okay, but sometimes you have to convert those remote sensing satellite data set into Excel sheets so that you can analyze the patterns in the form of charts. Okay, so let's begin our analysis for today. Okay, so we will analyze rainfall time series for Chennai between 1984 to 2024, because the data with just CHIRP, where is that? Yeah, it is CHIRP daily precipitation data. It is available from since 1984. Okay, so we are going to use these generalized line of code. Okay, first we are importing the Earth Engine, and we will import the plugin map so that we can plot our dataset on our QGIS interface. Then we will define our region of interest, which is going to be Chennai district. If you want, you can change the name of the variable here. Okay, again, I want to tell you that the way we write codes in any programming language, first we have to define the variable. Okay, so it is always defined in the form of variable. So here we have defined our region of interest by the name Chennai, in which we will use a feature collection from FAO dataset, and we will analyze, we will actually extract the level 2 Chennai district. Okay, this is level 2 is our district data set, and we will pick up its geometry. Okay, so let's copy this much code here and paste it on Python console. Okay, Python console of QGIS. So before that, let me also open this OpenStreetMap. Okay, and let's run this code. Okay, so it has taken our it has selected our data set. Okay, because the data set we will use here, it's going to be the series of images. Okay, or that will be the images of different time period. So that may not be, or it will be downloaded, exported in the form of CSV. The data set we will and get will be in the form of CSV. So you may not get any changes here. Okay, you will not find many of these changes won't be visible on your map. This will be only visible when we are exporting our data to Google Drive, and from there we will download the data and we will load that raster into our QGIS. Okay, so here it is important that you understand the codes first. Okay, next we are going to load our data. We are extracting the CHIRP data from Google Earth Engine dataset. Okay, this is image collection because it varies with time. Okay, so that's why it is saved in the form of image collection. It is not a single image. Okay, fine. It is, if you want to see whether it is executed correctly or not, you can see in this area. Okay, you do not see any error. That means it is executing correctly. Okay, so now we have to define our years and months. Okay, so what we are doing here, we are creating one more variable, years, in which we will get the list. Okay, so years are in the form of list, which will be from 1984 to 2024. And months, of course, we want from the first month of January to December, 12th month. Okay, that will be our December for each year between 1984 to 2024. Okay, for all 40 years, we want this data. So we are going to define our year and month. If you want, you can make changes here. Okay, if you want to do it for a certain time interval. Okay, so let's run this. Run the selected. Next, we will generate annual images. Okay, if an annual images, there will be years. Okay, this dot map, and there will be we are making we are defining this variable in which we are filtering the data. Okay, and within that data we want to filter out the calendar range, which will be year. Okay, which will be within our bounds, area bounds, and we want to calculate the mean because this is our daily precipitation data. So we want to calculate the mean for the entire year. Okay, so the image that you will get will be the mean of a particular year. Okay, so let's run this. Copy it from here, paste it, and select this much and run selected. Okay, and then what we are doing here, we are generating, because as I already said, this is our daily data. Okay, even for the monthly data, we have to take the average. Okay, for 30 days average we have to calculate so that we can get that average data into our CSV. If you want to do it for daily, okay, daily data, if you want to analyze the daily data, then you can change here. You can make the changes as daily. Okay, so just copy this. Almost like most of the time people are analyzing the monthly data. Okay, so daily data is not that useful. It will be useful only in case you are identifying the flooding period. Okay, so how many days the flooding was there. Okay, so if you want to do that, just make those changes here and you are good to go. Okay, just copy and paste it here. So I will expand it like this. And here, monthly years, okay. And simply run it. Okay, fine. This looks fine. Here, what we have done, we have filtered out the calendar range, year, and then month. Within Chennai, okay, we are taking the mean and whatever the band name is, whatever the size is, but it will be greater than 0. Okay, and if it is 0, we are also considering the 0. You see here, we are also considering the 0 values. Okay, and again, what we are doing here, we are unmasking the zero values. If there are zero values, then if there are zero values, we want zero values, greater than zero values, and whatever the area is left between, then we are unmasking it. Okay. Now let's export this data into our CSV. Okay. So we are exporting task is common for all the codes that we have written so far. Okay. Let's control and run the select part. Okay, so the task has been started. If we go to our Google Earth engine, we can see this is updating. Okay, and here it is downloading the data for us. It is contacting the server. So by the time it is happening, like let's move ahead and let's see how we can get the images. Okay, now if you want to export task for all the year images, okay, if you want to get the data for these years, because getting data for these 40 years will take a lot of time for us. Okay, during this class it is going to take a lot of time, but what we can do, we can at least check the variation between 1984 to 2024 in the form of maps, okay, in the form of images. So what we are doing here, because there are so many years, okay, so there are at least 40 years, so we are doing this in a loop. Okay, so we are using a for loop for year. Okay, for year, this is the year. In years, in this variable, we want chirp image to filter out the calendar range. In this year section, we have to define for which year we want it. Okay, let's say I want this for 1984. I want first image for 1984, so I will use 1984. I want this within my filter bounds. I want to calculate the mean for entire 1984 year. Okay, now clip this within Chennai, and here you can again set the year. Okay, because this is not a string, so we have to define the year here as well. Okay, so once it is done, we can run our task and export the data in our folder. Okay, so here if you want to specify the name, Chennai Precipitation 1984 and 1984. Okay, so the scale you can define for what scale you want. Smaller the scale, more time it is going to take. Okay, so I have kept it 100. Let's see how much time it's going to take for us. So this line of code will give us the data for 1984, the mean precipitation of 1984 in Chennai area. Okay, in Chennai district, at the scale of 100 meters. Okay, so let's run this code here. Let's run this entire code. Okay, okay, the name task is not defined. Oh, sorry. We haven't taken this line of code, right? So we have not defined the years. And yeah, here we have to define the list of range between 1984 to 2024. Hmm. Yes, now it's fine because we removed the indent. So that's why it was throwing error, because we are using loop, okay, for year in years. So that's why we have to keep everything within this loop. Okay, within the indent from where we started our image variable, we have to give the task variable for the same image. That's why this indent is important here. Okay, so let's see if our precipitation data is downloaded. Oh, okay. This Excel sheet is downloaded. Okay, let's open this in Drive. And this is the one. We can see it from the time. And let's download it. This is the CSV file that we have got for 40 years of data. Okay. And here, week 4. Okay, it's already there with me, but I will keep it as the name. Okay, so let's open this. Excel sheet. Okay, it is giving us the multi-point data. Okay, so I'm going to delete this column here. And this is for, you see, this is for first month of 1984. Okay, this is the mean precipitation. This is the second month of 1984, February, March, April, May, June. Okay, in this way it has given us the data for 1984, 1985, 86, 87, and for all the 40 years. Okay, you can see this Excel sheet. We have got the data, and now for individual year, we can perform the time series analysis, and at the same time we can compare the precipitation. Okay, I'll show you how you can do it for at least 4 to 5 years, and the other, because it is not possible to do here for all the 40 years, but in the same way you can do for 40 years. Okay, so I will use this chart option here. Yes, you can also calculate the average value. Okay, with this Excel sheet, you can calculate the average value for an year. Okay, you see, we have first, let's adjust. Oh, sorry, I am here. Yeah, let's adjust this x-axis. Okay, up to maximum of 12 months. Okay, I think this is fine, and here we can give the minimum bounds to 1 month. Okay, now our chart fits quite well. So I'm going to increase the size so that you can see it in a better way. Okay, I hope you all have used Excel for your analysis. Okay, the precipitation is not in the negative, so we are not going to use, okay, the values are, yes, the values are greater than 0. So let's keep it 0. Okay, now for this is for 1984. Okay, now what we are going to do, we are going to add add the variation of precipitation for 1985. Okay, this much data we are going to add. So for that, what we are going to do, we are going to right click and select the data. Okay, we will add the series here, and for X value I'm going to use this column of 1985 from first month to the 12th month. Okay, click on this button here, and for Y series, remove this part and then select the Y column, which is your precipitation. Okay, then you see we have got the chart in as compared to 1985. Just for this 2 year comparison, you can see like for within 1985 and 1984, in this time, can you see this peak? The precipitation has suddenly increased in the month of from the 10th month to the between 10th and the 12th month. Okay, from October to December, the precipitation in the year 1985 was abnormally increased. Okay, when we are comparing just 2 years, this can be one of our conclusion. Okay, now let's add one more series. For this, I'm going to use the 1986 data from 1 to 12. Okay, and then for Y, just remove this part and click on this button to select your data set 1986. Okay, so you see we have both the series here, and if I click on OK and see here, and you see again in the 1986, the precipitation has dropped quite significantly. Okay, you can see the peak here in the 1984, but sorry, 85. But for if you compare the 1985 and 1984 and 1986, then there is much less variation, which we can identify in 1985. Okay, let's add one more data set. Select the data, right click and select the data, add the series. Okay, so we have done till 1986. Now we will go to 1987. Okay, this much. Oh, sorry. This has to be not here. Cancel it. Add one more series. Okay, in the X value, we have to put this, okay? For 1987, okay? And what you can simply do, if you have selected the X value, just, oh, sorry. Let's remove this. Okay, we will simply copy this and paste it in the Y series. And what we can do, we will change the column, okay? We can simply keep it C, okay? And here as well, we can keep it C. Click on OK, and you see now we have got one more uh, uh, line showing the precipitation. Okay, you see among only when you compare these 4 years from 1984 to 1987, you can see the abnormal increase in the rainfall. Okay, abnormal increase in the year of 1985. Okay, so let's with this chart now we can, what we can do, we can just get the images for 1985, okay, and 1984. We can compare these 2 years in our map view, okay, just to visualize how and in which area this, because this chart doesn't give us the spatial uh, variation. Okay, it is not giving us the it is not telling us about the area in which this particular thing happened, okay, in which there was flooding, but we can identify such patterns using our map view, okay, which we can export using this set of data, okay, for which we have already executed this 1984 images. Let's see if it is already available in our Google Drive or not. Okay, so I will go here and I will see the task. Yes, I think it's completed. Okay, so let's open this in Drive. Okay, so it has downloaded data set for us. I'm going to download this. Okay, 1984. Okay, I'll just change the name to new and save it. Okay, let's do the same thing for 1985. Okay, for what you have to do here, you just have to change the year, because we using the charts we saw the difference, a lot of like significant difference between 1984 and 1985 precipitation pattern. So we want to see the same thing in the images, and using the images we can identify the areas in which this particular shift in the or the flooding happened, okay, because that peak shows us the flood time. Okay, so let's see what we can visualize now. Run the selected part, and hopefully our task will be started here. Will begin in, okay, it's updating now, and it is executing the task, and it is will start downloading it in few seconds. So let's wait for a few minutes. Okay, but meanwhile what I'm going to do, I'm going to bring that raster into my map, okay, into my QGIS. So I'll go to my folder where I downloaded this TIFF image. Okay, so I'm simply going to drag and drop it to my area of interest, and let's go to layers panel and just zoom in. Okay, let's see if it is, yeah, it's there in our drive. Oh, not the one, not this one. 1985. Okay. Yeah. You see. Okay. Now let's style them using the layer styling panel, single band pseudo color. Okay. I'm going to use this uh, blues color ramp so that we can see how the precipitation has changed over time. And again, single band pseudo color. Okay. Now, if you see in 1985 and in 1984, okay, can you see the changes? You see in this particular area, This is actually 5,000 by 5,000, but from here you can understand that in this particular area in 1985 there was more rainfall. Okay, maybe the peak that we are, I mean, you have to confirm it with the reports of that time. Okay, but the peak that you are seeing, you can see here, shows you that this was the time of flooding. Okay, this was the time of abnormal precipitation in Chennai. But our task next objective was to identify the area in which this particular thing might have occurred. Okay, so when we plot the difference, when you plot the rasters from 1984 and 1985, we can see the significant changes in this particular area. Okay, you can see here this in this particular pixel, you can see that there is a significant increase in the precipitation. Okay, so this is how you can make use of charts. Okay, you can make use of charts as well as your maps. So both the presentation, both way of presentation is quite important when you are doing your geospatial analysis. Okay, when you are performing your advanced geospatial analysis, both the way of visualization, data visualization, and presenting your maps and charts become equally important. Okay, and you see in this particular area, if you notice in this particular area, the precipitation has not changed much. Okay, you see it can be seen with the same color, maybe a slightly darker one. Okay, but all these areas has received a significant change in the precipitation. Okay, which shows that there is a significant increase in entire Chennai area.